Hello everyone. Today we are here with a new topic of mathematics, that is triangles. We all know about triangles. The triangle is a three-sided polygon. We all have learned in our previous classes the triangle is having three sides, three vertices and three angles. In the class 9th, we have learned about congruency of triangles. That means if there are any two figures which are overlapping each other, if we are going to keep one over the other, if they are going to overlap each other, exactly overlap, then the two figures are said to be congruent. In this chapter, we will be learning about similarity. It is little bit similar with the congruency, but not exactly same. Like in the congruency, we were saying that if there are two figures are there with the same shape and with the same size, they are said to be congruent. But for similarity, if we are having two figures with the same shape, although it is not compulsory to have the same size, then they are said to be similar. That means we have to compare any two figures with the same shape. It is not compulsory that they are having the same size also. If it is the condition, that means figures with the same shape but not compulsorily same size, then such type of figures are said to be similar figures. We will be comparing the same type of figures. Like if we are comparing a rectangle, so we will be comparing it with a rectangle only. If we are comparing a square, so we will be comparing it with the square only. We can't compare a square with a rectangle, because the figures should be similar. The shape should be similar, although size could differ. Like if we are going to take an example, suppose we have taken the map of India and one is in A4 size and another is in A3 size. So although both the maps are of India only, that means their shape is same, but their size are different. So such type of figures which are same in the shape but different in the size, they are said to be similar figures. It is not compulsory that the size should be different only. It could be same also, but it could be the special case where the figures are said to be congruent also. So we can say that all the congruent figures are similar also, but all the similar figures are not congruent. Now if we are going to see, suppose we are taking a square and we are comparing it with another square. If the sides of all the figures, means both the two your squares is same. If it is 4 centimeter, the side of this square is 4 centimeter and the side of this square is even 4 centimeter, then two squares are said to be congruent. Now, but if the side of one square is 4 and the side of another square, suppose it is your 5 centimeter, then these two figures will be similar. They won't be congruent. They will be similar in shape. So we can compare two squares together. We can compare two circles together. And if we will see that if we are going to compare any two circles, then they will be similar. Although their radius could be different. One of the circle with radius 3 centimeter, another circle with the radius 5 centimeter, both of them will be similar. Similarly, we can say if we have taken two equilateral triangle, one with the side your 3 centimeter suppose, and another equilateral triangle with the side 4 centimeter. So both the two equilateral triangles will be similar. So whenever we are taking any regular polygon means their angles will be equal, all the angles will be equal and all the sides will be of equal measure. So if we are going to compare two polygons with the same number of sides, regular polygon we are comparing, if the two regular polygons are there and their number of sides is equal, then they will be similar to each other. Although the length of the side, the measure of the side could vary. If the measure of the side is even same, they will be congruent also. But if side is different, in that case they will be similar. Here in this chapter, we will be learning about similarity of triangles. Now see some properties, important points, that all the congruent figures are similar. Just now we had discussed. So if we will be taking any congruent figure, they will be similar, although it is not compulsory that all the similar figures will be congruent also. Two polygons with the same number of sides are similar. Whenever we are comparing any two figures, Any two similar figures means same figures, like a rectangle with a rectangle. So any polygon or any figure, if we are comparing, they will be similar if there are two conditions are satisfied. One, their corresponding angles are equal, and the ratio of the sides, corresponding sides, is equal. If these two conditions are fulfilled for the two figures are said to be similar. That means two polygons with the same number of sides will be similar if their corresponding angles are equal. Means whatsoever the corresponding, the word corresponding is very important over here, that their corresponding angles are equal. Suppose I am talking about triangle only, it is not an equilateral triangle, suppose, and I am saying ABC and DEF. These two are the triangles. So if I am saying that a triangle ABC is similar to triangle DEF, triangle ABC, the sign for the similarity is this, DEF. If I am saying this, that simply means that angle A will be equivalent to angle D, angle B will be equivalent to angle E, and angle C will be equivalent to angle F. That means A corresponds to D, B corresponds to E, and C corresponds to F. If this is the condition, we cannot say that ABC is similar to triangle EDF. No, this is not true, because angle A is equivalent to angle D, angle B is equivalent to angle E, and angle C is equivalent to angle F. Whensoever two figures, two polygons are similar, that means their corresponding angles will be equal and the ratio of their corresponding sides will be equal. That means ratio of AB over DE will be equal to BC over EF, will be equivalent to AC over DF. But this won't be true, because this means that A corresponds to E. That means according to it, the angle A should be equivalent to angle E. Although for regular polygons it is true, but not for irregular polygons. So two polygons with the same number of sides are similar if their corresponding angles are equal and all their corresponding sides are in the same ratio. Now suppose we are having three polygons with the same number of sides. That means three polygons, suppose we are talking about three hexagon. So hexagon, if we are comparing three hexagons, and if first hexagon is similar to the second and second hexagon is similar to the third, so automatically we can say that the first hexagon will be similar to the third hexagon also. That simply means if one polygon is similar to another polygon and their second polygon is similar to the third polygon, then first polygon will be similar to the third polygon. If, as we say, if A is equivalent to B and B is equivalent to C, that simply means A is equivalent to C. Similarly, if one polygon is similar to another polygon and second polygon is similar to third polygon, then first polygon will be similar to the third polygon. As just now we discussed that for similarity, two conditions should be satisfied. One, their angle should be same, corresponding angles should be equal, and second is that their corresponding sides should be in the same ratio. So this ratio, the same ratio of corresponding sides, is referred as scale factor or representative fraction. As we are just saying, if these two figures are similar, that simply means AB over DE. If ABC is similar to DEF, then AB corresponds to DE will be equivalent to BC over EF will be equivalent to AC over DF. In this ratio, so the same ratio of corresponding sides, it is referred as scale factor or representative factor. So it must be clear that two figures are said to be similar. For that, we need to prove two things: that their corresponding angles are equal and their corresponding sides are in the same ratio. In this chapter, although we will be discussing about triangles only, what all criteria are there by which we can prove the similarity of triangles. Before coming to the criterias of similarity, let's see one of the very important theorem, that is basic proportionality theorem. It is even abbreviated as BPT, and it is also known as Thales theorem. The derivation of this is very important, and directly and indirectly it is being asked in most of the years. In the board examination, it is always asked, either directly it is being asked to prove the theorem, or sometimes in any of the question it is being asked to solve it. So it is a very important, so please focus over here. See, according to the basic proportionality theorem, if a line is drawn parallel to one side of a triangle, if we are going to take a triangle, suppose a triangle we have taken ABC, and we are going to draw a line parallel to one of the side of the triangle. Here we have drawn a line DE which is parallel to one of the side of this triangle, that is your BC. So if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, which is intersecting these other two sides at distinct points, AB at D and AC at E. At two distinct points, it is intersecting the remaining two sides of the triangle. Then other two sides are divided in the same ratio. Then these two sides are divided in the same ratio. That means AD over DB will be equivalent to AE over EC. So what is given to us is that in the triangle ABC, this DE is parallel to BC. This is the line DE which we have drawn parallel to the side BC. So given to us is in triangle ABC, DE is parallel to BC. And we have to prove that AD over DB is equivalent to AE over EC. This is to be proved. For this, we will be constructing from E, we will be drawing the perpendicular on the side AD, that is your EN will be the perpendicular. From the point D, we will be drawing perpendicular on the side AE, that is DM is also the perpendicular. Along with that, we will be joining DC and we will be joining BE. This is the construction which we have to make, and whatsoever the construction we do, it is always done with the dotted lines. So this is the construction that we have drawn, EN perpendicular to AD and DM perpendicular to AE. This we have drawn. Now what we have done except this is, we have joined CD and we have joined BE. This is the construction. Now how to prove it? Now see over here in this triangle, if we will take the triangle ADE, the area of the triangle is 1 upon 2 base into height. If this is the triangle ADE, if we are going to take AD as the base, in that case EN will be the perpendicular or the height. So area of this triangle could be 1 upon 2 into base, that is AD is the base and EN is the height. So area of triangle ADE will be 1 upon 2 base AD into height EN. This is the area of triangle ADE. We need not to write always the triangle sign, because area of, if we are writing ADE, it means area of triangle ADE only. So it is not required to write the sign also. Now we have taken the area of triangle ADE. Now we will be taking the area of BDE. BDE. This is the triangle we are taking. In this triangle, your BD is the base and again the height is your EN is the height. So for this triangle BDE, area will be 1 upon 2 into BD into EN. So we have taken the ratio of area of triangle ADE to area of triangle BDE. That will be 1 upon 2 into base is your BD and height is your EN. Now if we will be solving these two, 1 upon 2 will cancel. EN and EN is going to cancel. So it will be AD over BD. Suppose this is your equation number 1. Now what we are doing is, again we are taking the same triangle ADE, but now instead of this as the base, we are taking AE as the base. So if AE is the base, height will be DM will be the height. So area of triangle ADE, again it could even be written as 1 upon 2 into DM, which is the height, into base is your AE will be the base. And whether we are taking this as the base or this as the base, the area of the same triangle will be same only. So we know that this area, whether we are taking AD or the base or we are taking AE as the base, in both the cases this area will be same only because it is for the same triangle. So now we have taken AE as the base. So area will be 1 upon 2 into DM into AE. Now in the denominator, we will be taking the area of DEC. This triangle DEC we will be taking. Here the base will be EC and height will be DM will be the height and EC will be the base. So area will be 1 upon 2 into DM into EC. Now if we will be solving it, 1 upon 2 is going to cancel. Along with that, DM is going to cancel. It will be equivalent to AE over EC. This is your second equation. Now, if we are going to see these two triangles, triangle DEB and triangle DEC, so we can see that both the two triangles are on the same base DE. Both are having the same base DE and both are between the same parallels DE and BC. We have studied in class 9th that if there are two triangles with the same base and they are between the same parallels, then their areas are equal. That means area of triangle DEB will be equivalent to area of triangle DEC. Why? Because both are on the same base, that is DE, and both are between the same parallels, that is DE and BC. So because both the two triangles lie on the same base and between the same parallels, that's the reason they will be having the same area. Now if we will be comparing these two parts, this part and this part, we can see area of ADE, area of ADE. Obviously they will be same because they are of the same triangle only. And just now we have said that area of triangle BDE will be equivalent to area of triangle DEC because they are on the same base and they are between the same parallels. That means this part is equivalent to this part. Numerator was already same and we have proved denominators even same. That means ratio of this will be equivalent to ratio of this. So we can say that AD over BD will be equivalent to AE over EC. Just now we have proved that area of this triangle is equivalent to BDE is equivalent to area of DEC. So from these three equation, we can say that AD over BD is equivalent to AE over EC. And this was to be proved. So we will be writing hence proved. It is very important. Just go through it and learn it. Now let's see the corollary of BPT. That means by BPT only, that is basic proportionality theorem, what we can interpret. In the BPT, we have seen that if in a triangle, we are going to draw a line parallel to any one of the side. Here, we have drawn a line DE which is parallel to BC. Then, this is cutting these two remaining sides at distinct points in the same ratio. That means AD over DB will be equivalent to AE over EC. This was the BPT which just now we discussed. Now here again given to us is that there is a triangle ABC in which DE is parallel to BC. What we need to prove is AD over AB will be equivalent to AE over AC. It is a part of your question only. From the exercise it is a question, although it is a corollary of BPT also. So we need to prove is AD over AB is equivalent to AE over AC. So given to us is that in triangle ABC, DE is parallel to BC. It is given to us and we need to prove that AD over AB is equivalent to AE over AC. Now how to prove it? In triangle ABC, DE is parallel to BC. It is given to us. And by BPT, we can say that AD over DB will be equivalent to AE over EC. Just now we have proved the BPT. So because these two lines are parallel in a triangle, that's the reason AD over DB will be equivalent to AE over EC. By BPT, we have taken it. Now, if this is the case, if we are going to reverse both of them, both the ratios, if we are going to reverse, then also they will be equal. So we have reverted it and it will become BD over AD. This we have taken as a numerator and this as the denominator. This reciprocated it. So it has become BD over AD is equivalent to EC over AE. And now if this is the case, if in the LHS and RHS we are going to add the same number, we can do that. Its value won't be changing. So we have added in the LHS also we have added 1 and in the RHS also we have added 1. It won't make any change in the value of this equation. So we have added in both LHS and RHS, we have added 1. Now if we will be solving it, AD will be the denominator and the numerator will be BD plus AD. In the right hand side, AE will be the denominator and the numerator will be EC plus AE. From the figure, we can see that BD plus AD could be written as AB. BD plus AD could be written as AB. So instead of BD plus AD, we can write AB. Similarly, EC plus AE could be written as AC. So we have written AC. Instead of BD plus AD, we have written AB. And instead of EC plus AE, we have written AC. Denominators are same here. Again, we can reciprocate it. If this is the condition, we can reciprocate it even. So it will become AD over AB is equivalent to AE over AC. And that was to be proved. So it is hence proved. So either directly we can use BPT, or it is the corollary of BPT that even we can use for solving the question. Although it is even one of the question of your exercise. Now we will be doing converse of BPT. As per BPT, if in a triangle, we are going to draw a line parallel to any one side of a triangle and which is intersecting the other two sides at distinct points, then these points will be dividing in the same ratio. This line will be dividing the other remaining two sides in the same ratio. Now, converse of BPT says that if a line divides any two sides of a triangle in same ratio, that means suppose we have taken a line DE in a triangle BABC, then if AD over DB is equivalent to AE over EC, then the line is parallel to the third side. Then this line AE will be parallel to the BC. Now means we have to prove that in a triangle ABC, if DE is a line which we have drawn in such a way that AD over DB is equivalent to AE over EC, then we need to prove that DE will be parallel to BC. This is the converse of BPT. Now given to us is that in triangle ABC, DE is drawn, DE a line we have drawn which is not parallel, which is not yet given to us it is parallel. We need to prove it that it is parallel. Simply it is given that DE is a line we have drawn such that AD over DB is equivalent to AE over EC. It is given to us. Suppose this is your equation number 1. Now we have to prove that DE is parallel to BC, which we have to prove. Now what we'll be doing, we are assuming that DE is not parallel to BC. Simply we are assuming that DE is not parallel to BC, and if it is not parallel, obviously we can draw from ED point, we can draw a line which will be parallel to BC. So we are assuming that the line DF which we have drawn is parallel to BC and DE is not parallel to BC. So this is our construction which we have done. DF, which is we are assuming that this is parallel to your BC. So let DE is not parallel to BC. So we can draw a line DF such that DF is parallel to BC. If it is not parallel, obviously we can draw a line. So we are assuming that this is not parallel and we can draw a line DF which will be parallel to BC. Now if DF is parallel to BC, just now we have read BPT that if this is parallel to this side, that means AD over DB will be equivalent to AF over FC. If DF is parallel to BC, then automatically by BPT we can say that AD over DB will be equivalent to AF over FC. This is our second statement. Now if we are going to compare the first and second statement, the LHS part is same. Here LHS part is AD over BD. Here also LHS part is AD over BD. Here RHS part is AE over EC and here RHS part is AF over FC. So we know that if there are two equations in which one of the side is same, that means the other side will even be same. That means over here, if this is equivalent to this, we can interpret that this part will even be equivalent to this part. So from equation 1 and 2, we can say that AE over EC will be equivalent to AF over FC. Now, If we are going to add the same number in LHS also and in RHS also, their value is not going to change. So we have added 1 here in the LHS and we have added 1 in the RHS. So LCM over here will be EC. Numerator will become AE plus EC. And in the right hand side also, we will be taking the LCM, that will be your FC, and numerator will become AF plus FC. Now if we are going to see the figure, so AE plus EC, AE plus EC will be AC, we can write it equivalent to AC. Similarly, AF plus FC, some of these two could even be written as AC. So from the figure, AE plus EC could be written as AC and AF plus FC could be written as AC. Denominators we have kept it as it is. Now because here the numerator part is same, so it will be cancelled. It will be 1 here and 1 here. That simply means FC will be equivalent to your EC. And how it is possible that EC is equivalent to FC? It is only possible then when F and E are going to coincide. But what we had assumed was that F is another point. It is not the same as E. So why this contradiction is arising? Because whatsoever we had assumed was actually wrong. It is not the distinct points. They are the same points. Actually, DE is parallel to your BC. So points, this could be possible. Points E and C coincide, which is not possible as they are distinct points, because it was our assumption that your point F and point E both are the distinct points, and as per this they should coincide each other. So this contradiction arises due to our wrong assumption, because our assumption was wrong, which we had assumed that D is not parallel to BC, and we are drawing in another line DF which is parallel to BC. This our assumption was wrong. Basically DE is parallel to BC and hence proved. So this is how we can prove, by imagining, by your assuming that whatsoever is we have to prove is not correct. So by this way we can prove it out. In the starting of the chapter, we have seen that two figures are said to be similar if their corresponding angles are equal and ratio of their corresponding sides are even equal. If only the corresponding angles are equal, or if only the ratio of the corresponding sides are equal, then we cannot say that the two figures are your similar figures. For proving the figures to be similar, it is compulsory to say that all the corresponding angles are equal and the ratio of their corresponding sides are even equal. In the chapter your congruency, we had even seen that if there are some criterias, if these criterias are fulfilled, then we can say that the figures are congruent. Similarly, in similarity also, there are some criterias, and if these criterias are fulfilled, then we can say that the figures are similar. We need not to prove that all the angles are equal and all the corresponding sides are in the same ratio if these particular criterias are fulfilled. Let's see what these criterias are. Theorem it is, if in two triangles corresponding angles are equal, that means if there are two triangles we have taken in which their corresponding angles are equal, that means in triangle ABC and triangle DEF, two triangles we have taken in which angle A corresponds to D, B corresponds to E and C corresponds to F. That means if in these two triangles angle A is equivalent to angle D, that means if it is angle 3, it is even angle 3. If this is your B is angle 1, then E is also angle 1. And if C corresponds to F, that means if this is angle 2, this is even angle 2. That means if there are two triangles in which the corresponding angles are equal, then their corresponding sides are in the same ratio. We need not to prove that it will be in the same ratio. It is already there that if there are two triangles in which corresponding angles are equal, then their corresponding sides will even be in the same ratio, and we can say that the two triangles are similar. And this criteria is known as AAA similarity criteria. Now how we can say that if only three angles are in corresponding angles are same, are equal, then their sides will even be in the same ratio. Let's see. So here we have taken two triangles. One is your ABC, another is your DEF. in this triangle DE is greater than your AB and DF is greater than AC. So what we had done by construction, we have taken a point P such that DP is equivalent to AB. In the triangle DE, we have taken a point P such that AB is equivalent to DP. Similarly, we have taken a point Q on DF such that AC is equivalent to DQ. That means AB is equivalent to DP and AC is equivalent to DQ. These 2 points P and Q we have taken in the triangle DEF. Now, if we see these two triangles, then see this angle 3 is equivalent to angle 3. This angle 1 is equivalent to angle 1 and this is equivalent to this. This is so we have taken by construction. And by points we have selected this point such that AB is equivalent to DP and AC is equivalent to DQ. This we have selected these points. Now we have joined these two. Means what we have done, we have taken two triangles, one triangle ABC we have taken, another triangle DEF we have taken such that angle A equivalent to angle D, angle B equivalent to angle E and angle C equivalent to angle F. Now what we had done is, we have cut DE into two parts such that DP is equivalent to AB and DQ equivalent to your AC. Now if we will compare these two triangles ABC and DPQ, if we are going to compare these two triangles by construction, your AB is equivalent to DP, AC equivalent to DQ and this angle A is equivalent to angle D. That means by SAS, these two triangles will be congruent. That means triangle ABC will be congruent to triangle DPQ by SAS criteria. These two triangles will be congruent. And we know if the triangles are congruent by CPCT, their remaining parts will even be equal. That means till now we were knowing only that this angle 3 is equivalent to 3 and this side is equal to this side and this side is equivalent to this side. Now by CPCT we can say that angle B will be equivalent to your angle P. That means this angle is 1, so this will even be 1. Similarly, if this is angle 2, this angle will even be 2 because these two triangles are congruent. Just now we have proved. So by CPCT we can say that these two angles will be equal and these two angles will be equal. Now if we are going to see this triangle, then this angle 1, both the two angles are equal and they are corresponding angles. So if corresponding angles are equal, then the lines are parallel to each other. So by CPCT we can say that angle B is equivalent to angle P and it was equivalent to angle E. That means because corresponding angles are equal, these two lines, that means PQ will be parallel to EF. Now in a triangle by BPT, just now we have seen that if we are drawing a line which is parallel to any one side of a triangle, then other two sides are divided into the same ratio. That means DP over PE will be equivalent to DQ over QF. Or by corollary of the BPT, we can say DP over DE. DP over DE is equivalent to DQ over DF. We had just discussed that what corollary of your PPT is. So by that we can take it. Now see, DP by construction we have taken it equivalent to your AB. So DP could be replaced by AB. By construction we have taken DQ equivalent to AC. So this DQ could be written as AC. So this could be written as AB over DE is equivalent to AC over DF. That means AB of this triangle over DE of this triangle. Ratio of these two sides is equivalent to AC of this triangle over DF of this triangle. Means ratio of two sides is equal. This we have proved. Similarly, we can prove that AB over DE is also equivalent to BC over EF. And once the ratio of all the three sides of a triangle is equal, already we had taken that all the corresponding angles are equal, we can say that the two triangles are similar to each other. So this is how, if all the three angles are, if all the corresponding angles of a triangle are equal, then without even proving that their ratio of the sides will even be equal, we can say that the triangles will be similar, and this criteria is known as AAA similarity criteria. Now we know that in a triangle, the sum of all the three angles of a triangle is 180 degree. So if any two angles of the corresponding two triangles are even equal, then also we can say that the two triangles will be congruent, not congruent, it will be similar by a similarity. Because see, if any two angles are equal, automatically third angle will even be equal, because sum of all the three angles is 180 degree. So if any two angles are even equal, corresponding angles of two triangles are equal, then also we can say that the two triangles are similar. That means if two angles of one triangle are respectively equal to two angles of another triangle, then two triangles are similar by a similarity. So we need not to prove everything. Simply, it is the conclusion. We can conclude that if either two angles of one triangle is given equivalent to the corresponding two angles of another triangle, if either this is the case, of if all the three corresponding angles are given equal in two triangles, then we can say that by a similarity or by a similarity, these two triangles will be similar. Just now we have seen one of the criteria of similarity, that is a similarity or a similarity. Now let's see the another criteria of similarity. If in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence two triangles are similar. This criteria is known as SSS criteria. That means if we have taken two triangles, one is your ABC and another is your DEF, such that the ratio of their sides are equal, that means AB over DE is equivalent to BC over EF is equivalent to AC over DF. We have taken two triangles such that this ratio of their sides are given equal. Then what will be happening? We will be proving that how these two triangles will be similar. How we can say that their angles will even be equal. So again what we have done is we have said that DE is greater than your AB. This triangle, sides of this triangle are greater than that of your this triangle. So we will be taking a point P on the side DE such that AB is equivalent to DP. And on the side DF, we will be taking a point Q such that DQ is equivalent to AC. So we have taken 2 points, one as P, another in Q on the sides DE and DF respectively, such that DP is equivalent to AB and DQ is equivalent to AC. And we have joined these 2 points. So we have cut DP is equivalent to AB and DQ is equivalent to AC, and we have joined these 2 points. Already it is given to us that the ratio of their sides are equal. That is AB over DE is equivalent to BC over EF is equivalent to AC over FD. It is already given to us. Now by construction what we have taken as DP is equivalent to AB and DQ is equivalent to AC. So DP over DE. See, instead of AB, because by construction we have taken both of them equal, so instead of AB we can take as DP. So over here we have written DP over DE, and instead of DQ we have written, instead of AC we have written DQ. So instead of AC we have written DQ. So from first and last we can interpret that DP over DE is equivalent to DQ over DF. If in this triangle DP over DE is equivalent to DQ over DF, so we can see that this is corollary of your BPT. And if it is true, that simply means by BPT we can say that PQ will be parallel to your EF. These two sides will be parallel to each other. This PQ will be parallel to EF. Now if these two are parallel to each other, then this angle and this angle, both are corresponding angle, so both of them will be equal. This angle Q and this angle F, they are corresponding angles, so they will also be equal. So we have proved that angle P is equivalent to angle E and angle Q equivalent to angle F. This will be done. Now if this is the case, then if we are going to see the triangle DPQ, one of the triangle we have taken DPQ, another triangle we have taken DEF. In these two triangles, Angle P is equivalent to angle E, angle Q equivalent to angle F, and D is common. So we can say that this triangle DPQ is similar to DF, DEF by AA similarity or by AAA similarity. So these two triangles will be similar. If these two triangles are similar, we can say their ratios will even be equal. The ratio of the sides will even be equal. That means DP over DE will be equivalent to DQ over DF will be equivalent to PQ over EF. Right? We can say PQ over EF. Now, if these are true, that means from here, it is EF is here and it is BC. That simply means value of BC will be equivalent to your PQ, because this is equivalent to your PQ over EF and PQ over EF, and it is even equivalent to BC over EF. That simply means we can say that PQ will be equivalent to your BC. If BC and PQ both are equal, so in this triangle ABC and the triangle DPQ, AB is equivalent to DP, AC is equivalent to DQ, and BC is equivalent to PQ. So we can say by SSS criteria, congruency, these two triangles will be congruent. And if these two triangles are congruent, this angle P, corresponding angles will even be equal. So this angle P will be equivalent to angle B, this angle Q will be equivalent to angle C, and this angle D will be equivalent to angle A. And if in these two triangles the corresponding angles are even equal, already corresponding sides were in ratio, it was given to us. Now just now we have proved that the corresponding angles are even equal, so we will say that the two triangles are similar. That simply means if it is given, then the two triangles, the ratio of their sides are equal, then we need not to prove the angles to be equal. Directly we can interpret that by SSS similarity, the two triangles are similar. Till now, we have seen two criteria of similarity of triangles. Let's see the third one. If one angle of a triangle is equal to one angle of other triangle, that means we have taken two triangles in which one of the angles are equal and the sides including these angles are proportional. That means this angle is included between the sides AB and AC, and this angle is included between the sides DE and DF. That means if AB over DF is equivalent to AC over DF and angle A is equivalent to angle D, in such case two triangles are similar, and this criteria is your SAS, side angle side. The criteria, by this criteria we can say that if there are two triangles and in one triangle of a triangle, one angle of a triangle is equal to the one angle of other triangle and the sides including these angles are equal or proportional, then the two triangles are said to be similar. So what we have taken is, we have taken two triangles, one is your ABC, another triangle we have taken as DEF, in which again DE is greater than your AB. Here the angle A is given equivalent to angle D, and this angle is included between the sides AB and AC, and this angle is included between the sides DE and DF. So the ratio of these two sides are given equal to us, means it is given. Now what we will be doing is, again we will be taking a point on the side DE. The point will be P such that DP is equivalent to AB. Similarly, the point Q on the side DF is such that AC is equivalent to DQ. So this is what we have selected, the 2 points on the sides DE and DF, and we have joined these 2 points PQ. So what we have done is, we have cut DP is equivalent to AB and DQ equivalent to AC, and we have joined PQ. PQ we have joined. Now see over here, it was given to us is that AB over DE. AB over DE is equivalent to AC over DF. Now because AB is equivalent to DP, we have taken the point such that only, and AC equivalent to DQ. So we can write this as, instead of AB, we can write DP. So DP over DE is equivalent to, instead of AC we have written DQ. DQ over DF. And if we will see in this triangle, if DP over DE is equivalent to dq over df, it is your corollary of your BPT. And if it is true, that simply means by BPT, PQ will be parallel to your EF. We can conclude from here that PQ will be parallel to EF. And now if we will see the triangle ABC and triangle DPQ. In these two triangles, AB is equivalent to DP, AC is equivalent to DQ, and this included angles are even equal. So by SAS, these two triangles will be congruent. And if these two triangles are congruent, we can say that by CPCT, their corresponding parts will even be equal. Already it was given that these two angles are equal. So angle B will be equivalent to angle P. Angle C will be equivalent to angle Q by CPCT, because just now we have proved these triangles to be congruent. And even we have proved that PQ is parallel to EF. If PQ is parallel to EF, so this angle P and this angle E are corresponding angles, so they will be equal. This angle Q and this angle F, they are corresponding angles, so they will be equal. So if these angles, means angle 1 equivalent to angle 1 here, this two angles both are equal, these angles are even equal. So in two triangles, if all the three corresponding angles are equal, we can say the two triangles are similar. So this is how we can prove that the two triangles will be similar if one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional. By SAS criteria, they will be equal. We need not to prove it. Simply if it is given, we can say that the two triangles will be similar by SAS criteria. So since now, till now, we have studied three criterias. One is your AAA, or we can say AA criteria. Second is your SSS or SAS criteria. Now along with this, one more criteria is there, that is your right angle triangle, that is RHS criteria. In this, if there are two right angle triangles are there and in one hypotenuse and one side ratio is equivalent to the ratio of the hypotenuse and the other side of another triangle, then these two triangles are similar by RHS criteria. If in two right angles, triangles of hypotenuse and one side of one triangle are proportional to the hypotenuse and one side of other triangle, then the two triangles are similar by RHS criteria. Now let's see what angle bisector theorem is. Although there is no such theorem in the book written, it is a part of question only. There is a question in the exercise which is the same by this method only. This is only the solution for that question, but it is even known as angle bisector theorem. What it says is, if there is a triangle, suppose there is a triangle ABC and we are drawing AD such that it is bisecting this angle A. That means this angle 1 is equivalent to angle 2. Then in that case, we need to prove that AB over AC is equivalent to BD over DC. This is your angle bisector theorem. So what is given to us is that there is a triangle ABC and AD is bisecting angle A. That simply means this angle 1 is equivalent to angle 2 because AD is the angle bisector. Now we have to prove that ratio of these sides, that is AB over AC, it is equivalent to BD over CD. This we need to prove. For that, what's the construction we will be doing? We will be drawing a line parallel to AD which starts from C. Line from C we will be drawing which will be parallel to AD. That simply means AD is parallel to your CT. From where this T point comes, we will be producing this BA, and wheresoever it will be touching this line, that point will be your T point. That means we will draw a line through C which is parallel to AD. Through C we will be drawing a line which is parallel to AD and which meets produced AB at T. And when we will be producing this line, both of them will intersect at the point T. That means AD is parallel to your CT. Now, if these two lines are parallel to each other, we can see that Z is formed. That means angle 2 will be equivalent to angle 3 because they are alternative interior angles. Angle 2 and angle 3, they are alternative interior angles, so both of them will be equal. Similarly, we will see these two lines parallel, so angle 1 will be equivalent to angle 4 because they are corresponding angles. So angle 1 is equivalent to angle 4 and angle 2 is equivalent to angle 3. But we already know that angle 1 is equivalent to angle 2. That simply means angle 3 is even equivalent to angle 4. Because it is the angle bisector, so angle 1 was equivalent to angle 2. We have just now proved that angle 2 equivalent to angle 3, angle 1 equivalent to angle 4. That simply means all these four angles are equal to each other. When these angles are equal, and if we will see the triangle ATC, in this triangle ATC, angle 4 is equivalent to angle 3, and we know that the side opposite to equal angles are even equal. That means side opposite to this angle 3, that is your AT, and side opposite to this angle 4, that is your AC, will be equal to each other. Because angle 3 is equivalent to angle 4, that's the reason AT will be equivalent to AC. From here we interpreted angle 3 equivalent to angle 4, and because sides opposite to equal angles are even equal, that's the reason AT will be equivalent to AC. Hope it is clear till now. Now see the triangle TBC. If we will take this triangle, in this triangle AD is parallel to your CT. So by BPT we can say that BD over DC is equivalent to BA over AT. Because in this triangle BTC, AD is parallel to CT. That's the reason BD upon DC will be equal to BA over AT. This we can conclude from here, and just now we have said that AT is equivalent to AC. By BPT we concluded AB over AT is equivalent to BD over CD. Now just now we said that AT is equivalent to AC. So instead of AT we can keep AC. So it will become AB over AC is equivalent to BD over CD, and that was to be proved. That AB over AT is equivalent to BD over DC. This we had proved, and AT was equivalent to AC. That's the reason AB over AC is equivalent to BD over DC. Hope this is clear to you. This is one of the questions from the exercise, and you must have known or understood what similarity is, and whatsoever the criteria of similarity, it must also be clear to you all. Soon we'll be coming with questions related to this chapter in other video also. So till then, thank you.